Hello everyone, welcome back to MGF 1131. So in the previous video in section 8.2 we talked about simple interest, and the simple interest is amount of money you earn or you have to pay based on the principal amount for 1 year, and if the second year then you still apply the interest rate on the principal. Now we're gonna go ahead and switch to another type of interest we call the compound interest. And the difference between compound interest and simple interest is that for the compound interest, you apply you compound it many times, and you apply the interest based on the accumulated amount every year or every month, depends on the number of being compounded. Okay, so in the compound interest you're gonna make more money, or you're gonna have to pay more money to the institution. Okay, now we're gonna go ahead and start with the formula, and we're gonna go through some example. Okay, so let's get started. Section 8.4. Is that 8.4? Let me go ahead and check it again. Yeah, 8.4. Section 8.4. Compound interest. Okay. And the formula for compounded interest will be A, which is accumulated amount, equal to P principal 1 plus. Remember, for the simple we can have plus RT, but this one we're gonna have plus R over N, and represent the number being compounded raised to the N times T. So N, the T is the time, so T is in year. Okay, in year, and N represent the number being compounded. So if it compound daily, then N will be 360. So if it compound annually, then N equal 1. If it compound semi-annually, then N equal a half. Okay, and it compound quarterly, so N equal 4. And you're gonna have monthly, then you're gonna have N equal 12. Okay, and so on. You're gonna compound daily, minutely, and if it compound continuously, then we have a different formula. Okay, now we're gonna start with example. So as long as we know the principle, we know the how many times compounded, we know how long is the apply that interest or interest rate. R is the rate. Then you can find A easily. Okay, let's start with the first example here. Okay. You see, I'm gonna go ahead and bring up a problem. Let's see, I have it here. So I have the problem here, but let me see. Oh, let me see. I can go ahead and type it over here. Oh, I'm gonna go ahead and do like this. I think it's much better. So we're gonna do this problem. Okay. Okay. Example number 1. So Katie invested. Hopefully you can see this. Okay. Kathy invested $3,000 in a savings account with interest rate is 1.8% compound monthly. If Kathy make no more order deposit into the account, determine amount is 7 after 2 years. Okay, so we know everything, so we can go ahead and start it. So A equal, see, this is what happens. P is original, the principal is 3,000, 1.8, and 2 year monthly, compound monthly. So 1 plus monthly should be 12. and for 2 years it will be n will be 12 times 2, and the rate is, see, I forgot, 1.8, so 1.8 will be 0.018. Now we're gonna go ahead and put this into the calculator. Alright, so go ahead and put it into the calculator. Now put it in. Okay. So if you don't have calculator, so just do calculate over here, you know. So this one gives you 3,000. 0.0015 raised to the 24. Okay, and put into the calculator this one, you're gonna end up around 3,109.88 dollars. So you see the original is 3,000. So after 2 years, it's $3,109. Oh, just a little bit, $100 more for each year. So you see that it's not really that good, right? If you want to do investment for this type of for this kind of account, right? That even this after 2 years, it doesn't give you much money, only $109 more. All right, okay, but that's how you calculate. Now let's start with the second example. It will be a little bit different. Now let's bring up the second example. Okay, the second example was, okay, if the investment account paying 3% interest compound daily, when will the amount in account be twice the original principal? Sorry, I have some kind of noise in the background, but be patient with me, okay? Give me 1 minute. Let's see, I can fix the noise. Okay. All right, it's better now. So we're gonna do the same thing, but now they ask you for the t, because it's ask you when. I mean, they ask you to find t, and we're gonna use. You see, look like the second example. We use the number in the first, the principal as the first example. So $3,000, and then when they ask you how long it takes to double that, so it's double. And we can use $3,000, or even they doesn't have to say that. We can also calculate the t, because if the accumulated amount is twice the original, it means you're gonna have a will be 2p, and this is p, and 1 plus daily will be 365. And the interest rate is 3%, so you're gonna put a 103 times 365t. Okay, so our job is to find a t. Now you see that we can go ahead and cancel the p over here, so we're gonna end up with 2 equal, and now we're gonna calculate whatever inside the parentheses. So put into the calculator here. So 0.03 divided by 365. Add 1. Ooh, it's a pretty crazy number. So give you 1.0000822. Okay, raised to 360 times t. Now, in order to solve for the t, you need to use the principle called the log principle. We're gonna go ahead and take a log both sides. So I'm gonna go ahead and take ln2 equal to ln of this 1.0000822 raised to 360t. Then you're gonna drop this one down to the front, so you're gonna ln2 equal to 360t, ln 1.0000822, and you calculate the t. So t over here will be equal ln2 divided by 360 ln 1.0000822. Okay, so let's see what I give you. So I have ln2 ln2 divide by 360, and we continue divide by ln of 1.0000822. Okay, which is give you 23 years. So 23 year and 4.22. So you see that it's like 23 years. So you see that it take a lot of time in order to grow double. All right, it's like 23 years. That's why I say this is not good for such an interest rate, because it's only 3%, you know. But in reality, many institutions give you less than 3%. You like some of them get just like 0.1%. So how long is it going to take in order to double? So think about it. Put it in the money in the saving account is not good, right? And so even if they give you the compound interest rate, that's still not good. So you got to do something else in order to make money from investment. Maybe some other account that's very risky. The riskier it is, the more money you may make. But this is the 7 plane, and if it is 7 plane and then it's 7 plane, then it's not good. Okay. Now let's start with another one. Okay, here let's see. I'm gonna go ahead and bring another one. All right, in example number 3, you know what? I think I'm gonna do example number 3 later as example. I'm gonna do something else. How about if I do this one right here? Oh, this one I don't have a question, so I think you guys have to write a question with me. Example number 3. Okay. So let's write a question with me. So I have here in 2001 the median salary for occupational therapist was 85,570. 85,570. Okay, here approximately what salary would a person in this field need in 2041 to maintain purchasing power, assuming the inflation rate were 1%. Okay. All right. So in order to I guess I'm gonna use different color for how we use different color. All right, here. Okay. So now sitting there, look like they're talking about inflation rate, and if they talk about inflation rate, or we're gonna use another type of formula. We call continuously compounded interest. Okay, so continuously compounded interest. It means you compound it forever and ever. Okay, that is very ideal case. However, in the inflation case, that's what it is, because this inflation is going up all the time. Think about it. 20 years ago, you have a gas price $1, and now you have gas price $4 or $5. Okay, so in the next 20 years, the gas price probably $10, $15. So it is always going up. So that's why we use continuous compounded interest. And the formula is A equal PE to the RT. Okay, so everything the same, but they have an E value in your calculator. And we're going to use this formula to calculate the amount of money, the A value. Okay. The person need if the interest rate, the inflation rate is 1%. So we're gonna put 1% here. Okay. In 2004, so 2001, 2041 is 20 year. Okay, so we're gonna go ahead and plug it in. So A equal 85, 570, E 101 times 20 years. Okay. And you put into the calculator. Okay, let's go ahead and put it into the calculator. What give you? So 0.01 20, and you put E raised to that. Okay, so we have to find the E thing. Where is my E thing in my calculator? Oh, right here. Okay, 1, 2. Okay, then you multiply by 85570. Give you 104. 515. So after 20 years, if inflation rate is only 1%, then he has to make $104,000. That's crazy. And so you see, even the interest rate, even the inflation rate is only 1%. You see that the difference between $85,000 and 104 is like $20,000 different. You see that in 20 years. So look like every year the company has to pay you 1,000 more so that you can afford life. I mean that's crazy. I mean I don't think I don't think institution pay $1,000 more every year. So maybe a couple hundred, but 1,000 more. Think about that. Like let's say you have like $85,000 you make this year, and next year they're gonna pay you 86, and then following year will be 87, and so on. That's crazy, man. I don't think there's some institution paying that much. And to be honest, I don't know what the inflation rate right now. If you have any information about that, we can go ahead and look it up. But if you have any information about that, just let me know, okay? All right. So example number 4. We're almost there. Okay. All right. Example number 4. Let me go ahead. We're gonna use this. Okay. Example number 4. So I'm gonna go ahead. Is there a way we can go ahead and do the screenshot some way somehow and put it over here? Copy. Can we paste it like that? Let's see. Paste. Yeah, I don't think it's work that way. Yeah, I cannot do the pasting. So I have to save it. Let's save it in the maybe save it in here. Today is 517. Okay, then we're gonna copy and paste here. Yes, no. 517. Here you go. Here you go. There you go. Okay. I'm not. I thought I lost it. Okay. That's good. All right. So in this example, the first question is very similar to what we are doing right now, but the second one is they're asking you for the effective annual yield. So let's deal with the first one. Let's deal with the first one. The first one is easy. So we're gonna find the future value up to 1 year. Okay, so we're gonna go ahead and find the future value up to 1 year. So here will be $4,000 up to 1 year. So interest compounded monthly. So we have 1.08 monthly is 12. 1 year is 12 times 1. Okay, so which is give you 1.08 divided by 12 plus 1 raised to the 12 times 4,000. Give you 4,331.199 cents. Okay. All right. So now we're gonna do part B. Now part B is we have a new terminology here: effective annual yield. What is effective annual yield? What is this? What do you have 66 over here? Do we have this something like that? I don't think we have 66. Okay, guys, delete the 66 over here. Okay, it should be the question mark for some reason. I don't know why they come up with 66. All right. What is effective annual yield? So effective annual yield, it is the rate. Okay, it is the rate of we can call it effective rate. Okay. This is the rate for simple interest. It's the rate of the simple interest, which is we learned in the previous video. Okay, and that simple interest earn the same amount in 1 year as the money invested 8%. Okay, interest compound monthly. So they ask you to find the interest rate for the interest rate of the simple interest rate that generate the same amount of money as you use for the interest compound monthly 8%. That's what it means. Okay. So how we gonna do that? It's very easy, because right now think about it. You generate this amount of money. Okay. You generate this amount of money for the compound interest monthly, and you want to find the interest rate in the simple interest rate formula. So we can have 4,000 here, and you can have 1 plus RT is 1. Okay, that's a formula we have to use because that's what for a simple interest rate. Then now we're gonna go ahead and find the R here. So we can have R plus 1 equal to 4,331.99. You divide by 4,000 and give you 1.08299. So the R will be, you subtract by 1, so 0.08, so 29, so about 8.3. So 8.3%. So 8.3% is the simple interest rate. Okay, that help you generate the same amount. Okay, generate the same amount of money you have for compound interest rate. You know what I mean? Okay, so now, so in order, we can use this way, or there's another way to calculate. They ask you to use they want you to use the formula. It'll give you the same thing, but I don't think that is the good way to, because you have to memorize the formula. It's not good. So it's good that you're gonna go ahead and apply this method here, okay, and you calculate the effective annual yield. Okay, so this is 8.3 is the effective annual yield. So annual yield. So we have another name we call it effective rate. Okay. And the 8% over here, it has another name we call the nominal rate. Okay. All right. All right. So for example, for different scenario, I'm sure you should be able to handle the homework. It's not really that hard. It's very easy as long as you really understand it. You know how to use the calculator. Of course, you have to do carefully. Then everything will be fine. All right. So that's all for section 8.4. Next time, we're gonna jump to something more interesting. We're gonna talk about annuity in section 8.5. Okay, 8.5, and we're gonna talk about on the other method of a saving investment. We mentioned it, but there's no calculation. We probably learn how to calculate the relation to financing car or the cost of ownership, but the method or your method like you stock or anything, there's no calculations properly. We don't have to go through this, but we have to calculate. We need to go through the annuities. Okay. All right. That's all for the section 8.4. And if you have any question, please send me a message to Canvas Info. I'll be seeing you next time. Bye bye.